Right, hello, welcome to an impromptu, another one, yet again. Just an IMVU Hangout. Whoops. That was YouTube in the background. Yeah, so, working on this project for IMVU for Halloween, and thought it might be interesting. To just go over this, well, to continue the project with the next steps that might be of interest, and that is, this is for studio, or will be for studio, so let's just drop the, where's the avatar? So it's a torture cage, essentially, for Halloween. So we've got the avatar, it's scaled relative to the avatar, so we've got our rebar, and then we've got, well, we've got the large rebar, and then we've got these smaller panels, which will also be rebar. But what we're going to do is create a normal map and shininess map for these two mesh sections. And we're going to do them in a way that is relatively efficient. So what we'll do is use one texture and apply that to all the major rebar sections. And then we'll have another texture which will apply to the panels. But because we're using shininess and normal maps in particular, what we're going to do is make this mesh, or well, we're going to make these inner panels, these larger panels, we're going to make them double-sided. Because, and this is something that you will need to be aware of when you are working with normal maps in Studio, is that although, so we're going to make a grid texture for this, like that. And what you need to be aware of when you're making normal maps for these kinds of textures is that the way that IMVU does its double-sided thing normally is it literally just duplicates the faces. So they point outwards by default, it just duplicates and points them inwards. Now ordinarily that's not an issue because you can paint your, so if we imagine this is our thinner rebar, you can paint your shading on one side and your highlights on the other, and it'll flip the textures and it'll look reasonably okay. But with normal maps, because of the way that normal maps work, when it does that in IMVU, because normal maps are based on depth, height and depth, rather than shading, so if we look at the profile that we're going to create in our texture of this rebar, what we want to create is a normal map that'll have that sort of profile. So if that's flipped the way that IMVU will normally do it, the lighting, the way that this behaves to the light, will be inverted, so it will be backwards. So you have to compensate for that by duplicating and inverting. Well, you have to duplicate and flip the mesh manually, so you have to do it physically. So we have to duplicate these mesh panels. So I'll just do that. Object. Where's it gone? Duplicate objects. So that creates a duplicate. Press escape or right click depending on how you've got your mouse set up. And with that still selected, what we're going to do is edit mode. Make sure we've got everything selected. And so if we turn, so we can see we've got the material set up so that we're actually viewing backface culling. So the back faces of this mesh have been removed from view. Otherwise we'd get that. So what we'll do next is from the mesh menu, is flip. Where is it? Normals, flip. We're going to invert the faces. Like so. So we've got C1, C2. And ordinarily, that looks the same as, so if we disable backface culling, it essentially looks the same as if we've got backface culling disabled. So what we want to do is do that to the rest of the panels. And the reason, aside from the normal map, so we're looking at this profile eventually in the texture, but what we're doing is duplicating this for two reasons. We've got that profile, but also the way that the normal map will react to the lighting. So if we have a light source coming from this direction, it means the normal maps behave relative to the light source being on this side of the mesh. So when in IMVU, if we leave them as is and we do a two-sided mesh, what we have, and this is why the mesh, the texture will appear backwards, is because the inside is responding to the lighting from the outside. So the shading is backwards. So we have to adjust that by creating these duplicate faces, so we have a separate inside and outside mesh. So we haven't done anything special with the materials. We've assigned the same material to both inside and outside. So what's important in this instance is making sure that we have a duplicate mesh rather than a duplicate material. So let's just do that to the rest of the panels. Object, duplicate, press escape, edit mode, select all, mesh, normals, flip. And we can select, because Blender now has the multi-edit feature, we can select multiple objects. Let's just remove the avatar for the moment. So duplicate those, shortcut, Shift D, escape, edit mode, multiple meshes selected, select all, mesh, normals, flip. And that'll do all the ones that are selected. And we also need to do it for this front face. So duplicate, Shift D, edit mode, select all, flip. So if we just wireframe, just double check. Right, so select all of those in the outliner, and what we're going to do, left click drag, drop those in the cage collection, and then we're just going to do a little bit of organizing. Where have the panels gone? So that's box, box. Let's just hide the duplicates. That's the outside. So front, back, might have to panel front, panel back, panel left, panel right, panel top, and this is just panel bottom. This is just to organize the scene as we're working on it. When this is exported for IMVU, all of these will be joined together. So that's the bounding box. So that's panel front in. Side. That's panel left in. Panel right in. Panel top. Panel bottom. Panel back. Hello, Oofing. So have we got all of those? Yes, we have. Right, so as said, both sets of panels use the same material. So we don't need to do any double-sided shenanigans with the main rebar because those are just solid, essentially just solid tubes, cylinders. It's just a rebar cage. It's for a game. If you're not familiar with IMVU, it's for a avatar-based game called IMVU. So the avatar stands inside. Whoops. Inside a cage. So we're going to be creating some simple textures for these panels and these bars, essentially. So it's rebar, a rebar cage. But before we create the textures, we have to do a little bit of prep work. To make sure because we're going to be using normal maps and shininess maps, and we have to do some prep work to make sure the mesh or the model, well, the mesh behaves itself once it's in IMVU because of the way that normal maps react or respond to lighting. It doesn't affect shininess so much but it does with normal maps. So what we've done is basically duplicated duplicated these panels so that we've got separate meshes on the inside and the outside of the object, because we need to make sure that the normal maps on the inside of the mesh react properly with respect to scene lighting. So as we were saying earlier, if lighting is coming from this angle, the normal maps on the outside will react to that lighting correctly, but the way that duplication, well, two-sided objects usually work by default is that the game engines duplicate and invert the outside faces. When it does that, it means that the normal map that's then on the inside of the mesh is still behaving or reacting to the lighting that's on the outside of the mesh. So to compensate for that, we have to duplicate the mesh and invert a face or invert a section of it, whether it's a part or whole, so that it reacts correctly to the lighting. We'll see this once we get this all sorted out. But right, so that's that prep work done. So that's just the basics. But for the texture, what we've done is, so we've got our rebar, UV editing, select all, and all we've done, whoops, that's the wrong texture, rebar. So this is our rebar texture. It's a 512, yeah, 512 by 16 pixel. That's all it is. So for rebar, we don't need a complicated UV layout or complicated mesh. All we need is a simple image that we can repeat or use repeatedly on each of our objects. So they all use same UV, well, similar UV mapping. They're not all the same size from a UV mapping perspective, as we'll see in a second. Right, so they're all selected. Edit mode. So that's all the UV maps. So if we just island, just move these out of the way, well, to one side so that we can see the UV map. Oh, there's more than that. Oh, that's fine. There we go. Let's hide that. So this is essentially an optimization technique. Yeah, so that's the last one. So what we're doing, or what we're going to do, is create a tiling normal map for the rebar. And what that'll mean is that although the texture is only 512, as the UV maps for these larger sections extend beyond the boundary, the height boundary, it'll tile and we won't see any lines or breaks or issues on our object. So that's one thing to keep an eye on, is how you UV map these sorts of things. You don't necessarily need, let's just undo all that, you don't necessarily need to create complicated, unique UV maps. So ordinarily, for example, you might have wanted to do a 512 by 256 512 by 256 and then try and map. So if that was our 512, standard 512 by 256, what you might be tempted to do is map each section within the allotted space that we've got. So that's 4 taller ones and then 4 shorter ones, like so. Or is there 1, 2, 3, 4, 5? Oh, there's 6. So, oh, and then we'll have to squeeze one in here somewhere. But in doing that, because we've shortened, we want to keep the texture density, that is the amount of texture pixels that are used relatively to each size. So that's size 1 and that's size 2. We want to make sure that we don't get any extensive or obvious blurring between the two because of this difference here. So making these all relative to the texture size that we're using, so we're trying to fit the largest one within the bounds of our image, it means that the smaller ones, so that's these ones, they use up less texture space. So if we do a tiling texture, we don't have to worry about that. So we have our texture and we just map everything relative to their own sizes. Whoops. And we can extend the UV maps for the bits that we need beyond the limit of the texture space that we've got. But we have to make sure that we create the texture correctly. Right, so that's the rebar, the main rebar, and we'll do something similar, or we've done something similar with, so exit edit mode for that. Done something similar with the panels. So they are similarly all mapped to the same, same image. So for these ones on the side, we could actually squash these a little bit, inside and outside. So we are we are editing multiple meshes. So making our selections, edit mode. So we've got multiple UV maps now, and we just want to make these slightly thinner. So select all, check our pivot point. So cursor, that's at 0, 0. Pivot point, set to 2D cursor. So that's going to use this as our origin point for scaling. And then all we need to do, switch to the scaling tool and just scale. Have we got the right? Not sure why that's not updating in the 3D view. Because it should be. Oh, it's only done it on the inside. Hang on then, let's double check. So this is where the outliner comes in handy. Because when we've got meshes back to back like this, it can be tricky to select the sections that we want. Right, so we should have Dagnabby. Tab. Just test. Shortcut key. Yeah, I'm not sure why it's only doing the inside. Oh, that's why. That's totes weird. It is the same material. Backface culling. See, even Blender causes me some issues. Alright, so let's do this. Hide that, select, edit mode. That's probably why. Oh, now it's doing it. That's totally weird. So let's try that with the other two. So we're selecting using control here. So click, control, tab, edit mode. Why is it not letting us go into edit mode? There we go. Select all. Now it's doing it. Must not have had the thing selected properly. So what we want to do, again, texture density. So we've got this front face that fits the entirety of the texture that we've got, but the sides and the top, they're about 2/3 the width, so we have to reduce the width. Otherwise what we'll end up with, this is something again that we have to be careful with, is if we smush, so we've got this one mapped to the entirety of the texture. So if we have a grid, so if we just look at the grid of the actual color map that we've got assigned, so if we imagine that that's a grid texture, rebar grid, what we'll get is the rebar will look okay on the front, but on the sides it'll look squashed, and of course you can't squash rebar. So we have to compensate with the UV maps. So we want the front to be full scale, and then the sides so let's go to there. S. And I do the same for the top to make sure that. So we're looking at our texture. This is why you use the grid textures, by the way. So we're looking at our grid on the top, and we're looking at the grid on the side, and we're trying to match them up as best as possible. They don't have to be exact. And what that will do is it'll create the illusion of continuity and relative scaling. So it means that the image as is mapped to this side will be exactly the same or similar, very similar to the top, and it'll be the same for the bottom as well. Although let's just hide the grid floor. So again, we're looking at the texture grid, and we're trying to match those across. Whoops. For the same reason. And we'll want to do the same on the front and the top. So we're looking at the grid, front and top, and making sure they are matched up as best as possible. So essentially all we're doing is matching up as best as possible the way the grid, the eventual rebar texture, will appear on the mesh. We want it consistent. So literally, because we can't squash rebar when you think about it in real life, you can't just squash it to make it fit something. You cut it. So we have to make sure that when we make the texture that we accommodate this width on the side and the width on the top as well. So we have to be aware of the placement of our grid divisions when we make the actual image. And what we can do for that, actually, whilst we're here, is export this UV map so that we can use that as a guide. So for that we select our faces, then in the UV map menu go down to the bottom and we've got export UV layout. So click on that, it'll bring up the file window and we just save rebar cage UV sides. It'll save it as a PNG and we want the opacity to be set to 1 and export UV layout. So that's exported that, but what we also want to do as well whilst we're here is export the image. So we can do that, image, save as, rebar, let's just call this cage, rebar cage. And for this, you want to try and use a lossless format. So it's not that you should avoid PNG, but if bitmap is available, select that, Targa raw or TIFF. You want your images to be as raw as possible. Don't necessarily need red, green, blue, alpha, but leave that selected and that's all right. Save as image. And what that's done when it opens. So we've now got just have to find these. We've now got, where are they? Incidental music whilst we find oh, there it is. So that's the wireframe, that's the rebar wireframe. Where is cage? And there is the wire, well, that's the texture for the wire. So do the same thing for the rebar. So that's the cage. So we only need to select one. Rebar. That's our image. So again, it's a 512 by 16 pixel image. So image, save as. Rebar. Raw. That's okay. So what we can do with that now that we have two images, we don't need the UV maps for that so much as because everything's the same width. So now that we've got those, what we can do is bring those back into Blender as our materials. So shading, because at the moment we're just using generated images. So for this we want to replace the generated with our bitmaps that we just exported. So click on the folder icon. That's the rebar, so let's find that. There it is. So that's replaced that. It's kept the name, but it's replaced the source, which is now an image. Do the same again for the grid. Which is, there it is. Let's just go on this rebar cage. So we've changed the source type, so we're now using an image, a bitmap. So what we can do with this is save this file, save as 6. So just to make sure that we've got everything set up the way that it should be set up, we can do a test export. So the simplest way to do this is just to select everything. Just make sure we only have the bits that we need. So skeleton, that's disabled. Meshes, that's disabled. So this is an accessory item. So just select all. Make sure one of them is highlighted as the active object. So click it. Doesn't matter which one. And object, join. So we're joining all the meshes together to form a single mesh. So it collapses everything and we just get the single entry in here. So we can now call this rebar cage dot mesh. So the prep for IMVU. Thanks for stopping by, Oofing. And so what we can do now is the prep for this. So as it's an accessory, what we want to do is link it to skeleton.root, not skeleton.root, female 03 master root. So for the mesh, wrong one, there we go, select, edit mode, select all, and we want to be in, let's just move that back up, we want to be in object data properties, and we need to create a vertex group called attachment root. So click on the plus sign, double click and then just type attachment root, enter, and then we've got these buttons that have appeared. So we want to click on assign, so we're assigning this group to the entire mesh. So assign, and then we can test that. Let's just go into wireframes to make this easier to see. We can test that by using the select and deselect buttons. Hello Ahmed. And this will confirm whether the group is set up correctly or not. So once we've got that, what we can then do is link or parent the mesh to the armature, which is that bone. So select the mesh, then the armature. So we need to do two things here. We're going to actually parent it, so we're physically parenting the two objects together, but we're also going to assign an armature modifier. So the parenting, physically linking the objects together, it just helps with editing, because if we use just a modifier, the modifier only affects the mesh in certain views. So if we're in pose mode, which we'll do in a second, when we're in pose mode, it'll alter the mesh, but in object mode it won't, because it's mode dependent, so it's context sensitive. So we're selecting the mesh, skeleton, and then from object, parent, object, and then we get this little pop-up at the bottom. Click on that, expand it, and we want to make sure that keep transform is active and the type is set to object. So what that will now mean is if we select the skeleton and move it, it'll move the mesh. So if we undo that, just to see, it's just going to undo that, so that's Alt P. So we'll do the other one, which is the modifier. So if we assign the modifier to the mesh, so we select the mesh, we go to modifier properties. This only works when the mesh is selected. And we need to add an armature modifier. So click on that. It adds a panel. And we want to click on, because if we click on, normally you can click on this little square icon, but because this is an accessory, it lists loads of armatures. Each one of these represents a bone of the avatar. So an easy way of linking these things up is to use the ink dropper or the eyedropper. Click on that, and then click on the bone that we want to use, and it'll appear as the object. Now if they haven't changed anything, if we now select the skeleton and just move it, it doesn't move the mesh. So this is why for export you can get away with just using the modifier on the mesh, but for editing the project and managing the project, you want to use both of them. So assign an armature modifier to the mesh and link it to the skeleton. So that's one. And then what we want to do also is what we did just before, is physically link parenting wise. So we're now parenting the mesh to the armature as physical objects. So mesh, skeleton, object, parent, object, and keep transform. So again, that now means that we can move the mesh. So if we were doing something that had a skeleton that needed to move, or we needed to move the skeleton out of the way, and we didn't want to lose track of the skeleton's position relative to the mesh that we're working on, If we just use the armature, that will inadvertently allow us to move the skeleton on its own out of the way, which then means the mesh stays put and we cause a problem down here where we desynchronize. Is that a word? The mesh and skeleton are no longer positioned correctly relative to each other. Whereas if we use the parenting, we can move the skeleton to one side and it'll take the mesh with it, so the two of them are always linked. So let's do a quick export. Let's just save this file, save as 6B. Right, so for exporting, mesh, skeleton, file, export, FBX. We'll get the pop-up or the file browser thingy view thingamajig. What we want is selected objects. So set that. Don't need any of these. So the defaults can remain as they are. Transform, that's okay. Geometry, apply modifiers, that's okay. Armature, always disable add leaf bones. No animation, so deselect. Rebar cage 6B, export. So now in Studio, and this is the new version, so this is Studio 1.0. Right, so create. We want male accessory. Where is it? Men, accessories, skeleton, not skeleton, spectacles or shades. Oh, that's funny. That's the Halloween costume. So we've got our Halloween head. That's quite funny. Ha. How do we get out of this? Oh, there we go, down at the bottom here, look. Derive. That is funny, actually. I think I'll have to do that as a an outfit costume. Ha. Right, so import. So click on our asset button thingy, and we've got our import FBX. So click on that. We'll get the pop-up. And what we want is the FBX that we were just creating. So we called it Rebar Cage. There it is, Rebar Cage 6B. Open. So it gives us this preview. So it's found 3 skeletons, 2 meshes, 4 materials. We'll see what those are. So for this, we want to change the scale. First thing, 0.01, because we're using the starter files. And we need to set the correct skeleton. So it'll generally bring in 2 or display 2. We want the one with the lowest number of bones. So in this case, that's 2 bones, 1 mesh. So select that. It's got our mesh. That's good. Don't need to change anything else. Next. It's got our materials. So we can change these if we wanted to. So we just click on the icon and it opens up the browser and we just browse to wherever our textures are. It's got our material ID. Did we set the material IDs up? Hang on, let's just double check. No, we didn't. So it's automatically set up. So what we should have done is created the... Let's just do that actually. What has it done? It's assigned 0 to rebar. So 0 to rebar. So space, square brackets, 0, close square brackets. Let's just rename this rebar cage 1. Just save over that. So we can, when we get to it, we can re-export this. So that change doesn't really matter. So that's our textures. Next, no animation review. So that's what's going to bring in. Import. And it should, as expected, load it in at the head. So hopefully, all we need to do now, is that backwards? Looks like it's backwards. So all we need to do now is component. I hope they haven't changed something again. And skeleton. So that's our root node female. So that's a skeleton. And by default, it's attached. So we're now on this side. It's attached to the head. So we change that to female master root. Click, preview, and it should, there we go. So that's brought in our cage. So we've got a cage inside a cage. But you'll note it's replaced. The glasses have gone. So we don't have to fiddle around with that anymore. That's awesome. So let's just quickly throw, see if we've got a opacity that we can use. So click on the plus or the little icon. It'll bring up this window. Click on add image and just browse to an opacity that we can use. Let's just use Steam. Preview. So that's worked. So what we want to do next then is just play around with the opacity a little bit for this, because we'll need to do this in a minute. Well, not in a minute. Once we've done the might have to do this on a separate stream actually, doing the textures. Might do that later this afternoon. We've got composite blend. So we can use alpha test, set a threshold, and it changes the behavior of the transparency. So alpha test is so with the transparent textures, we've basically got something, when we use alpha test, we've basically got IMVU asking a question, is this transparent, yes or no? That's all alpha test does. Unlike the other one, which is composite blend, which should be more accurate, but oh, there we go. Composite blend works by asking the same question, but it asks an additional question in terms of instead of, well, two questions. So the first question is this transparent? Yes, no. And then the second question is the degree to which this is transparent. So it's then transparent based on whether it's white, grayscale, 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 down to black. No, is it white that's... Black's transparent. Yes, black's transparent, white's opaque. And grey, in between the two extremes, are different degrees of transparency. So for, well, the grid will be a simple texture, so we'll be able to use alpha test and with a threshold set, because we're just asking a simple, is this transparent or not? Yes or no. If it is, make it transparent. If it isn't, keep it there. And then we're setting a threshold that determines which textures or which pixels will determine the transparency. So we've lost a lot. Only got these little tiddly bits. So when we do grid textures, we can use alpha test. When we're doing something like the smoke, we'll use composite blend, because that gives us our grayscale values. But that's the, so we've just done our test and that works. So let's just save this. Whoops, wrong one. So hamburger file, save as, rebar cage 1, save. Right, so yes, I think what I'll do, or what we can do, call it quits there for now, and hopefully this afternoon we'll continue with the texture making. So this video, or this Hangout, was just basically about how you optimize your mesh to get the best out of what we'll eventually be using, our normal maps. So it's the normal maps that we're actually really paying attention to here. So we are duplicating, instead of relying on IMVU's double-sided setting, instead of relying on that, we're actually manually duplicating and making our mesh two-sided, because we want the normal maps to work properly with respect to lighting. So as was said earlier in the video, if the light source is coming in from this side and we've got a normal map assigned to the faces or the panel sides, as we look at the normal map, it behaves relative to the light source. So if we use double-sided, what we're essentially doing is flipping the outside to the inside, and it'll be using or responding to the lighting the wrong way round on the inside of the mesh. And in order to fix that or compensate for that, we have to physically duplicate and invert our mesh so that we have, let's go back to 6, so that we have, let's just hide these. So we have a front and a back mesh. So we've got two meshes. Albeit when everything's joined together, it's all a single mesh. But in order for this to work, pardon me, in order for this to work correctly, we need to manually and physically duplicate the mesh and invert it. So if we, so that's the front. Let's edit mode. Where are they? Normals. increase the size, and they might even be too tiny for IMVU because of the scale difference, and they are. So let's see if we can manually type a value. They're still too tiny. Right, so there we go. So those blue things indicate which way the faces are pointing. And for the front panel, they point outwards. For the back panel, they point inwards. And for the normal maps, because we can see both sides of the mesh, this is something that we'll have to start doing. So let's just select both of them. This is something that we'll have to start doing for true, air quotes, true double-sided meshes, because that's the only way to ensure that the lighting or the normal map as it appears on the inside of the mesh. So if we've got our lighting source coming from this side, the normal maps on the outside are responding to the lighting from that orientation. But if it's just double-sided, if you imagine that this normal is flipped and inverted, it basically means that the lighting is pointing, well, it's responding to the lighting in the same direction but inverted. So all it's done is it's inverted that. But what we want is for these normals on the inside to actually be responding to the light from the same direction. Let's just make that clean. So that's the outside, but also the inside. And the only way to do that is to duplicate the mesh physically and manually invert it. So we'll call it quits there, and in the next session, in the next Hangout, we'll go over making the actual textures. And it should be relatively straightforward, but we can get to play with, well, that will allow us to play with opacities. Right, so, yep, call it quits there, and we shall see you hopefully this afternoon, or in a couple of hours, where we'll make some textures. So, how long were we on for? An hour, that's all right. Right, see you shortly, hopefully. Bye for now.